Okay, for today, it's a little bit of review of right triangle trig. We're going to start you off with a nice simple one. This is 8. This is 20 degrees. Would you please figure out x? You're going to need a calculator for this one because I didn't make it a nice 30, 60, 90. I'm going to pause for a second while you try this. All right, so as you're looking at this, I hope you're realizing, well, the 20 is the one it gave me, and this must be the right angle. Otherwise, we can't do these. Yes, eventually we'll get to not right triangles, and we'll tell you how to solve those kind. You can actually do trig on not right triangles, too, but we're just going to do right triangles for a while. Did you do sine, cosine, or tangent of this puppy? Tangent. How did you know to use tangent? Somebody tell me how you thought it through. So if this is the angle it's got to be, we'll use the 20 because technically to use the 90, you can't tell the difference between these two. They would both be adjacents. So you can't really use the 90.
Okay, so then tangent is opposite over...
Yeah, and since you have opposite and adjacent sides, you have to use tangent to get that. There's no other function that would do it. You know why? Because the other two, sine uses hypotenuse, and cosine uses hypotenuse, both of which we don't have. So we can't use those. All right, tangent 20 equals x over 8 has how you set this up. And then you can either right now figure out tangent of 20, or you can times by 8 first. I kind of like this way better. Why? Because I've already got the answer. That is the answer. In fact, it's even better than what you get on a calculator. Why? Because it's what? It's exact. It's exact. It hasn't been rounded yet. See what I'm saying? In a second, I'm going to get tangent of 20, but it's going to be a decimal that's rounded. Now, every now and then, they come out to be nice decimals. Like, for instance, sine of 30 degrees is 1/2. It's a 0.5. That's, granted, it's a decimal, but it didn't have to be rounded. So sometimes, there's an exception for everything, but sometimes this isn't any more exact. But only if the tangent of 20 thing, that sine function thing, turns out to be an exact decimal. All right, by now you must have taken 8 times tangent of 20 and gotten a decimal answer. What did you get, sir? 2.91. Can anybody verify 2.91? About? Okay. And if yours is different than that, guess why? Probably rounded difference. You know what I mean? Maybe he rounded to the 1 decimal place and you rounded to 2 or something. Okay. All right, and see again why that's not awesome, because you can get 2 different answers from 2 different kids because they rounded different. So this is the only way to get it exact. All right, next thing. There was a few triangles that I asked you to memorize. The 30, 60, 90 was one of them. And I want you to just think about this. Do you get if I did the same problem here, same type of problem, and let's say I put a 10 here, you could do this by figuring out tangent of 30 equals x over 10. That would totally be okay and smart, but there would be another way because we happen to know this triangle's ratios. All right, then there's a third way, which is to set this up like this and then go to the little helper triangle, which I have memorized as the 1, 2, root 3 triangle, and I can use this triangle to tell me tangent of 30. You see what I'm saying? Go over here, look at this for a second, and tell me what's the tangent of 30. What is tangent of 30? Okay, we need some work on that. Either that or we need some work on you being able to talk. What is the tangent of 30? No. That's a decimal that's rounded. I want the exact tangent of 30. Yeah, look at it. I can see tangent of 30, can't you? Opposite over adjacent, 1 over root 3. So on a test, when they ask you, like, what's sine of 60, and you're like, how am I supposed to know that without a calculator? Okay, look at that triangle and tell me, what's sine of 60? Don't say it. Figure it out. Sine of 60. And the nice part about this is it's exact, too. It's not some decimal. Some other kid would use sine of 60 and get you some weird decimal. They'd have to round off. Otherwise, they'd have to be saying decimal places for the rest of their life. All right, write down what you think sine of 60 is and turn it my way, and I'll tell you if you've got it or not. I'll pause for a second while you do that. Sine of 60. All right, so here's a backup on this page. It was root 3 over 2. And now I've asked the kids to figure out cosine of 45, and I didn't even draw a triangle. I hope they know which triangle it is. Now turn it my way, and I'll tell you if you've got the right cosine of 45. That's the one. Yup, 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 yup. 5 people know. 6 people know. 7, 8, 9, 10, 11 people know. Yes, 12, 13. All right, good. So I know that's not all of you. If you didn't put yours up, it's probably because you didn't know what we were doing. It goes like this: 45, 45, 90, 1, 1, root 2. So then I look at either 45. It doesn't matter because they'll come out the same. Cosine is adjacent over hypotenuse, 1 over root 2. Sorry. Okay, so do you get why if we were in the middle of a problem and we wrote out this equation, a lot of kids think that without a calculator they can't do this, but they actually can. We just did it 2 seconds ago. Cosine of 45 can be replaced with 1 over root 2, and then I can just solve that. Tell me a one-step way to solve it. Yes. Yep, multiply by 8. A lot of people think you have to cross multiply. Nope, you just have to get x alone. 8 over root 2. The same thing you'd get if you cross multiplied. You did like 3 steps. Isn't it smarter to do 1 step if you can? All right. Okay, so there's just a quick review of kind of stuff we've done. Here's another one that I'm not going to fully do because it takes too long. We figured out if we needed to know the height of a building, we could figure out this angle. Let's say this is 50 degrees, and this angle, we walk a little closer, and let's say that this angle right here is like 70 degrees. And then all you need to know is how far you walked from here to here. Let's say that's 30 feet, and you should be able to find the rest. The key was you had to know that you needed this distance, right? If you know you need it, then you should label it. I'm going to call it y. And then I can set up 2 equations with 2 variables. Just set up the equation that has 2 variables in it for this part right there. Please set up that equation. Trying to get you refreshed here because the test is coming this Friday. We have a few things to learn before the test, but what was the equation that involved the 70 and the h and the y? Dice of destiny. Who should I call on? Row 2, person 4. That's you. Okay, or I guess CK. What equation can you do that involves 70? Hint, you'll probably want sine, cosine, or tangent of 70. That would be opposite over hypotenuse, but we don't know the hypotenuse. Swing and a miss, not sine. Try again. Tangent 70. Keep going. That's it. That's an equation. And could you find this with a calculator? Yeah, you could. And that means you have 2 variables in your equation. But you can't solve when you have 2 variables in one equation. But if you have 2 equations with 2 variables, you could solve it. And so you set up the other equation. The other equation in this case would be tangent of 50 is equal to, set up the rest of that. I'm not going to finish this problem. It takes too long, but I think the setup's okay. That's the equation that involves tangent of 50. You are correct, sir. Tangent of 50 would be opposite over adjacent, which is h over 30 plus y. Now, granted, that's going to be a nasty decimal, and that's not fun to solve. But anytime you have a fraction, your first step is to always get rid of the fraction. So you just multiply both sides by what? 30 plus y. That would clear that fraction. You wouldn't have fractions anymore. All right, enough about that. There, you're all up to date. Now, I started talking about this new lesson on Friday because or actually in your class, Thursday or Friday, one of the two. I just know you were at that 4-dimensional thing on Friday, or on Thursday or Friday. It was different in my different hours, so so confusing. So here's the Scrappy the dog situation. First of all, if I say he was traveling in that direction, do you get that would be about 70 degrees true? If you haven't figured out how these work yet, let me remind you. This direction would have been 90 degrees true. Also known as north, south, east, or west. East. Okay. East is the same exact thing as 90 degrees true. So if I'm heading in this direction, do you get this a little less than 90? And if I say it's 70, that's believable. This must mean 20 then, right? And this part is the 70. All right, just to see if you remember that, would you please show me you're out in the middle of the ocean and you have just been directed to go 278 degrees is your bearing. Take a bearing of 278. That's a fancy way of saying pretty much go west, but exactly where would it be? Would you please draw a little arrow and then turn it my way and I'll tell you if you're heading the right way. 278, that's correct. That's it. Yup, 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 yup. 278, good. Yup, just a smidge more than 270, right? Yup, 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 yup. Okay, so where's 270? 270 is right here, so 278 would just be a little bit more than that. In fact, how much more than that? 278 would be, well, if this is 270, then this is a difference of 8 degrees right there, right? Do you get how that can kind of make a nice little right triangle right there? Okay. Now, where they get more complicated is where you're changing from one kind of directions to another. If I said, north 5 degrees west. I also want to make a percent sign when I say degrees. 5 degrees west. Do you know where that is? That's not called true bearings. That's just north, south, east, and west. But would you tell me what it is in true bearings? First, draw yourself a little arrow. Like, let's say you think it's here. And then figure out how many degrees it is. North, 5 degrees west. I'm going to pause for a second while you piece that together. So let me explain the two different answers I got from people. It's supposed to be you're heading north, but then you're heading 5 degrees west of that. So therefore, it's actually there. Do you get where a kid might have thought west and then 5 degrees north of that? But that's not what I was talking about because I started with north. If I start with north, then you say, well, basically you're saying to head north. If you even missed the other part, at least you'd be close. North, but then 5 degrees west of that. And then if you're really there, then how far is it? Well, 360 would be all the way. Take off 5 of that. 355 degrees to get just to here. All right? So now, we're finally completely ready for the Scrappy the Dog question. But it's going to involve, he starts here, and then he stops, and then he goes from there. What I want to remind you is you can make 2 compass roses, which really help. Let's say that I knew that he was heading 50 degrees true. That would mean that angle right there is supposed to be 50. Can you see what angle up here also has to be 50? I can. Can you? If this one's got to be 50, can you see the other one? That's over on the other one. It's got to be 50. Because once you know a bunch of 90s and a 50, you'll know every angle over there. All right, so here's the way I like to explain it anyway. Remember the whole 2 parallel lines and a transversal thing? Kind of missed. I'm going to move it. There. Do you remember the thing called, I even said it on either Friday or Thursday, what were these things called? Alternate interiors. Those are the two that are the same. So do you get, if I know these are all 90, that's 90, this one's 90, and this one's got to be 90, but it's made up of a 50, and then I also know that. That has to be what? A 40. All right. Now, one more thing. It does matter how long Scrappy was running. That's a distance. It's not an angle. Let's say I put an 8 on here, and he was running for 8 miles. It matters because later they might ask you how long will he have to run to get back? Well, right now it's duh. He went 8 miles out, he'd have to go 8 miles back. But what if from here they send him at a 135-degree angle, 90 plus 45, which would make a 135-degree angle, and they send him that way for like 6 miles. Do you get all of a sudden we're shaping up, we've got a triangle going here, where our answer will be something like that? All right. Okay, so now, back to Scrappy. I'm going to pause while we pull up that problem. Okay, so now we got it down to that little pink triangle. I can use math, trig specifically, to figure out how big Q is. And I told everybody that we can now figure out this angle and this angle, those two angles that are left. This one and this little angle. These are not easy. They require a lot of logic and piecing things together, but things to look for. Number one, look for things that add up to 90 degrees. Number two, always look for those right triangles where you have one side and one angle in it, because then you know everything. You know all of its sides and all of its angles. All right, I'm going to pause for a second while you work on that. Okay. So did anybody actually figure out Q? You don't have to, but what did you get? Just see if it's the same as what he got. All right. Sine of 15 is opposite of hypotenuse. And oh, the hypotenuse is 1. I like it. Sine 15 is equal to opposite, which is Q, over hypotenuse, which is 1 in this triangle. And so Q over 1 is just Q, and therefore it's sine 15. I like it a lot. What is sine 15? Well, it's some decimal. Got it? 2.6. Anybody verify 2.6? All right. So then this right here must be 2.6. So are you sure about? Okay, thank you. I was like, okay. 2 people verified it, so I was really confused. Okay, 0.26. Because in the context of this being 2, I was going to say, how in the heck can that be 2.6? Okay, 0.26. I can believe that. All right. Now we come to some math that is needing to be outside the box. Did anybody go outside the box and look at this and this and this triangle? Do you get it's a triangle where we know an angle and we know a side? Think about it. To get the original side here is 2. I got to try a side of the big triangle. And that means I know everything for the big triangle. This is how big? Because it has to make a total of 90. This must be 30. That's 2. I can figure out all the sides and all the angles. Well, that doesn't really help me, Mr. Server. I mean, okay, that's great. It's another big triangle. Can anybody finish this deal? Finish it off? Yes. The pink triangle? Are you talking about the pink triangle? Or something like that? There will be a subtraction involved. Yes?
The thing that I did is I like.
Oh, did you figure you have a way?
I think so.
Okay. Tell me what you think.
At the top to that angle or that point or whatever.
This angle right here.
That point right.
The point. This point right here.
Right from that, you have a 45 triangle.
this triangle right here would have to be a 45, 45, 90. I'll buy that. And yes, you're on the right track. Oh. Yep, you got all the angles and all the sides then, if you have a side and an angle. So this must be 45, and this must be a right triangle. Keep thinking. What do you think? All right, I'd like you to walk up here and show them with a marker, because it's easy to get lost in all the words. Now, step to the side so they can see you.
You can take off the length, so you can subtract
That length, and show them the other one's the same as that. Show them the other one that's the same as that. That's the same as this then, right?
Yeah. So
Okay.
this. You can subtract the green height from the blue height, and you get the height of this line, which is the height of this triangle, and you can...
Okay, wait. So first, one thing at a time. Label that. Call it X. Do you get he's saying that if we know this distance, yes, there's a huge 30, 60, 90. Okay, so keep on explaining it. So do you get how he can figure out what X is? Do you get how he got figured out X or not? How about this? Do you get that X and let's call it something else. We're going to call this distance right here. X and M together make up the big blue side on the right. This piece, and this piece, and this piece can all work together. Okay. And then finish. How do you think we're going to finish this deal?
You can find, because it's the same concept, you can also get...
Wait. I'm going to call it out with a... We'll use... Okay, now you can draw again. Let's just move that off to the side. Okay. Set it back down. Pick it back up again.
So then you can say that this would be, say, y. And then y would have to equal this side, this side, big blue side on top, minus the green side on top of the 45, 90.
Basically, this side here and this side here are related to this whole side here. Is that what you're saying?
Yeah.
All right. And then what's your end game? Once you've got all that, what do you have? What kind of a triangle do you have? Or what?
You have a right triangle, so you can put that in here and say 2a squared plus b squared equals c squared.
Are you talking about this triangle right there at the end? Okay, I know that got really intense. And some of you are going to need to work this out on the problem that I send you home with, not this one, on a different one. That's a little simpler than this. Okay? But it involves a ton of right triangles. And here's the other piece. Do you get it involves like this side plus this side equals this whole distance here? You got to be able to see those kind of things. All right. And if you're like, oh, I will never be able to figure that out, you could still get an A on this next test. You just have to not understand everything else because you can't afford to make more than one dumb mistake, right? You write this off as your one thing you don't get. Then you need to get everything else, you can still get an A. What if you don't get this and something else? Well, then you can still get a B. All right. And I know it's the first time you've seen it. And when's the test? When's the test again? Friday. Do you think you're going to get a little bit smarter between Monday and Friday? I hope so. All right. So, I know those are challenging. And that's why I gave you a partner to work on it with them. And even that would, wasn't like it instantly solves everything. But do you get that most of your problems are going to be easier than that? Okay, good. So let's get to what your homework is. Everybody find day 2, which is right here. All right. A ship leaves Old Port and heads northwest. They have this little ship down here, okay, so they're kind of indicating that the ship's down here. Okay, so we got a ship down here, and it's heading northwest. Right away, I strongly encourage you to make a compass rose right there. Why? Because it's all about right triangles, and if you don't know where the right angles are, it's going to really mess things up. And he's heading this way. Now, a place he's actually going, I would make a solid line. That was not great. I'm going to try again, because that's got to be a 45-degree angle within that triangle. All right, so that means I just made a whole bunch of right triangles. I just made a right triangle here. I just made a right triangle here. This is 45. This is 45. We don't need to know all of that yet, but that should be like kind of what you're starting to think. Okay, that's the corner of a right triangle. All right. After covering a distance of 16, ooh, that's 16. It heads in a direction of, ooh, as soon as they do that, I always make these triangles big, by the way. It really does help your understanding if they're a lot bigger than if they're smaller. Zooming in and stuff is such a pain in the butt. Okay, now from here, anytime he changes direction, new compass rose. I'd always do with dotted lines too for me. It's up to you. If you maybe because you have different colors, you could just always make yours in green or something. You know, somehow know where you're making your compass roses. I do them with dotted lines. Okay, and now he's heading in a direction of north 6822. Ooh, pain in the butt. They use nasty decimals. Okay, well, we have to figure out what that is then. 68 degrees, 22 minutes. Do you remember that's 22 divided by what? 60, because it's minutes, right? So 22 divided by 60 is your decimal. So 68 point something degrees. You'll have to do a little division to figure that out. Use your calculator. 68 plus 22 sixtieths is some 68 point something decimal. I'm going to call it about 68. And because I'm just roughly drawing what this looks like. That's kind of this way. And it goes for 22 kilometers. That's a long ways. Oh, did I do it wrong? Oh, north 68 degrees west. My bad. Sorry. I was doing 68 degrees east. Sorry, north 68 degrees west. So that's more like that-ish. I know, it's not perfect, but your triangles don't have to be perfect either. We do need to know what the angles are, though. All right, and if that's 68 degrees is from the west, it's north, but 68 degrees west of that. That means that right there is your 68 point. Has anybody done the decimal for it yet? 68 point what? 0.37? Anybody verify that? All right. It's north 68 degrees west. So this is the correct angle right there. It's 68 degrees off of north. Another way to say it. All right, and he goes for 22 kilometers. That's 22. Where it drops anchor.
Why isn't it exactly?
Because they said 68 degrees, 22 degrees west. Do you read that? 68 and 22 minutes means 68 point something. In 22 minutes, this came out to the 0.37 when they divided it. So 68.37 degrees. If the world was simple, there'd only be round numbers of degrees. But do you get on a big ocean, being off even by half a degree makes a difference? So there's decimal degrees. Okay, so now we're going to go from here. And what is the final answer? Distance and bearing from Old Port. So in other words, how far is that? And what's its bearing? As in, from this compass rose up here, I can ballpark its bearing. Is that good enough, Mr. Server? No, it's about 135, but no, you're going to have to do the actual work to figure it out. That is a typical test question. This red line right here, I'm drawing in green now, that's a bearing. And it's more than 90, because that would be 90. And it's less than 180. It looks kind of like 135 to me, but I don't exactly know because there's even decimals involved. All right. What triangles? Yes.
Is it from where you started going now, or is it from where you are now to
Good question. From here to back home. It's like the ship wants to go home. Your homework is, listen please, that problem obviously, and that problem, and I'm going to just leave you those two. That's all I'm assigning for tonight is those two. Get them both done. Remember, there's a key. Saying, I didn't get what to do is really lame if there's a key posted. Take a moment to look through the key and finish these two. That's all I got for you for today.